Hello viewers, welcome back. In today's video lecture we are going to learn about the halogenation of alkene. In the previous lecture we discussed the hydrogenation of alkene. So where both the hydrogens are getting added into the alkene carbon through syn addition, and it is a stereospecific reaction that we learned, and it gives racemic mixtures. Here we are taking the bromine instead of hydrogen, you see Br2. So we may expect that it should also get added by syn addition, but not the case here. Halogenation will not takes place by syn addition, it undergoes by anti addition. You see, whenever there is an anti addition, whatever the atoms we are going to added in the alkene carbon, it should be represented by one is wedge bond and another is by a dash bond, vice versa. Okay, that's why we are getting a racemic mixture. The same case there also we have learned, and the hydrogenation of alkene also gives a racemic mixture. Okay, so here in simple, here both the bromine atoms are added in the alkene carbon and it gives a vicinal dihalide. Okay, so this is the overall reaction, and similar to hydrogenation, this also a stereospecific reactions. This is the overview of halogenation of alkene. Now why this halogenation takes place by anti addition, that we have to understand through its mechanism. Now you may get confused. You see here I put the bromine atom, one is partially negative and another is partially positive. Why it should like that? Both are similar electronegative atom. Why it should be like that? So please understand that when both the reactants, that is alkene and the bromine molecule, when comes close together, the pi electron of this alkene when approaches the alkene, the bromine atom, one of the bromine atom, the electron density is shifting towards the other end of the bromine atom. That's why here we are representing one of the bromine atom is by partially positive, another is partially negative. That is the reason. Okay, so when it is approaching this pi electron, and this excess of electron getting cyclized, so if you form cyclic bromonium ion, and this bromide ion getting cleaved, so this is getting departed, and now this cyclic bromonium ion is highly unstable. This bromide ion attacks in this direction. It will not attack this side, wherever this bromine phase, because there is some sterically hindered. So why it is not possible, by this way it will not occur. So why this bromide ion, whatever this cleaved, this bromide ion in the first step, that will come and attack the opposite phase of this bridge, this one, whatever the cyclic phase. So when it attacks by this way, this bond get cleaves and the positive charge of the bromine is getting stabilized. By this way, you see both the bromines are getting in the opposite direction. That is the reason the halogenation takes place by anti addition mechanism. Okay, and what is the use of this reaction? This reaction can be used in the qualitative analysis, test for unsaturation. What is meaning? If any unsaturated compound can be confirmed by this reaction, because the bromine is a liquid, that is yellowish orange liquid. Okay, this yellowish orange liquid, when we add it to this unsaturated compound, that this yellowish color suddenly it will get disappears. If it's happen like that, then we can confirm that. So whatever the compound is containing a double bond or triple bond, or you can say simply it is a unsaturated compound. So this reaction is mostly useful to identify or classify whether it is saturation or unsaturation compound. Okay, so this is very useful test in the qualitative analysis. Now So we learned the halogenation of alkene. Now next we are going to see the halohydrin of alkene. What is the main difference between the halohydrin of alkene and halogenation of alkene? Now you see here, the difference is here, you see here the CCl4. The CCl4 is here non-polar solvent, here H2O is a water is a polar solvent. That is the main difference. Okay. Now the mechanism will be the same. The first step of the reaction will be the same. This will go and attack this bromine, and so the bromide ion will get cleaved, but that bromide ion will not come and attack in this second step, because we took the water molecule in excess, that is act as a solvent. So that will react with this bromide ion and this will get neutralized. Okay, that is the reason. So this will not available, this bromide ion is not available for this attack in the second step. The water will come and attack. Okay, so that we have to consider. So when this water come and attacks, so this the same mechanism, the bromide, the positive charge gets stabilized, later we are getting by this way. You see here the bromine and OH groups are in the opposite. So this mechanism is also by anti-addition. Additionally, we have to understand one more thing. So we may ask that why it should not be like this. Anti-addition means I should get like this way also, no? Like this. Both. For example, the bromine may by this way and OH may here. Suppose like this. R3. This is R1 and R2. You see this. Here the OH group and here the OH group. Whenever this halohydrin takes place, the OH group always substituted at the highly substituted alkene carbon. You see here this alkene carbon is substituted with R1 and R2. You see, but here there is only one carbon. The one is hydrogen. That means this is less substituted alkene. So this carbon is highly substituted alkene carbon. That's why whenever there is an halohydrin reaction takes place, the OH will always added to the or substituted at highly substituted alkene carbon. So this we should remember. So these are about the halohydrin reaction. Sometimes this reaction may be twisted in this another way also. For example, instead of water, so it may be taken place in the alcohol also, in the presence of alcohol also. So if you react with alcohol, so what will happen? You will get, you see here I will put instead of this R. Okay, so here there is no hydrogen, there is R if you take that alcohol. So what will happen? So if this step is formed, this hydrogen will donated its electron to stabilize this oxygen's positive charge. Finally we may get by this way. Okay, so like this OR it will form. This is ether. Okay, so like this it will get formed. Okay, that's all. Okay, so if you understand the halogenation of alkene, anti-addition mechanism, the rest will be the same. And one thing only you have to remember, this OH group or the water will always substituted at highly substituted alkene carbon. So that is the key step you should remember. I hope you understand this reaction. Kindly subscribe and share this lecture if you find this lecture is useful. Thank you very much.